I'm going to talk about how we apply Earth observation to social and business challenges. So we're downstream, and we already work with a large number of customers. We have about 300 clients, most of them in the private sector, wide range of sectors, wide range of types of industries. We're providing information services to these businesses, of which the Earth observation element is one aspect. About 20% of our business is public sector. What do? We help organisations measure, monitor and manage environmental impacts and risks. Increasingly there's requirements on businesses, requirements on governments to show that their programmes are functional, to identify where the new risks are coming from and to report those. We combine Earth observation data with other forms of spatial data, such as maps, land ownership, soil maps, things like that, local information and internal business intelligence that those organisations have. We bring that together to provide the actionable information that companies then use to report or to manage. So where do we sit in the Earth observation supply chain? We're quite far down. We are dealing not much with raw Earth observation images. We're dealing with derived data products and information to end users. So we take what information from a wide range of sensors, turn that into information products, or even our partners often do that analysis or data processing. What we provide is spatial data infrastructure that companies can then combine it with their own information, use it in their systems. This is a successful process. So we now have, we started the company in 2008. We now have about 30 staff overall, of which the largest number are in Edinburgh. We have 3 salespeople in London. We have an office that's about 7 or 8 people in Montreal, and we're just opening an office in Boston. We had our first, we've got about 20 FTSE clients and one, what it was, the S&P 500 in the US. In terms of Earth observation, we see a number of challenges. First of all, the existing Earth observation data sets are very fragmented, and they're often funded on a project-by-project basis. The data that comes to companies is often, or is used by organisations, is often stored on individual hard drives and things like that. So, and requires a lot of reanalysis by GIS platforms. So what we are trying to do within our systems is automate a lot of that processes and provide central places where data products are stored. A very interesting illustration of this, last year we were doing some work funded by ESA for the UK government in terms of looking at what are the data sets that the UK can use to monitor the effectiveness of its forest programmes. We discovered that one country which had been funded to do a complete forest map and forest inventory, funded about £20 million dollars worth of work from the Finnish government, that whole data set had been lost. After about 5 years of work, the data set was just lost somewhere, somebody's desk. There wasn't, the consultant had left. Well, maybe it will be recovered sometime. So the scale, you can have wonderful technology. This was a data set that we put together with a combination of Landsat, LiDAR, all the wonderful things you can think of. But there was no attention to how the data would be curated at the end of the final product. So it's crazy, but this happens. So the platform that we provide is there to help with this process from acquisition. Well, what we mean by acquisition is not so much the ground station work, but acquisition into the company system on processing of the EO data products, managing that data on connected cloud storage to ensure that it's permanently stored, well protected, and that you can manage who has access to it and what queries can be run on that data. Because the data sets are large, the data is not downloaded to individual devices. What you do is you send queries up to the data set, that runs the queries and sends back the answer to your device. And we provide accessible and intuitive end-user interfaces so that people don't have to be experts to use the end information. One of the main deployments we're currently using, which I think could be of relevance to a lot of data producers, is the concept of an EO lab. We have just completed the installation of the first ones of these in Mexico as part of an IPSP project from the UK Space Agency. This EO lab really allows a regional research centre to bring together all the data sets that are relevant to that area. So in southern Mexico, they have an area of great extremely important biodiversity. They have archaeological areas such as the Mayan cities. There is questions regarding deforestation, sustainable agriculture. Lots of data has been produced over that area over the past 20 years. It's sitting in fragmented different organizations or different researchers' data sets. This is a way of bringing that data together in a single environment and then allowing Earth observation and EO-derived products to be overlaid onto that to produce sort of intelligent, useful applications. And so we're happy. One of the early results of that is that our Mexican partners have just managed to raise on the back of this EO lab, some additional conservation finance from the Global Environment Facility. It's a good example of how IPSP money has catalyzed additional investment. There's the EO lab although it's the data sitting on a cloud, it's situated in Chetumal. It has links to data projects going on in UK universities, the University of Edinburgh, Leicester and Imperial College. And they're initially using it for forest conservation and interactions. Silvopastoral, that's when you can have looking at the combinations of livestock and forests. Example of one of the corporate applications. This is looking at potential impacts of climate change on suitable growing areas for barley. This is not in Scotland, but this is in Africa, where barley is grown at high altitude to produce these sort of high quality beers that get grown in countries countries like Kenya. But because it's at high altitude, barley requires cold temperatures in order to mature properly. And so as temperatures increase, that reduces the suitable area because they're essentially being pushed up the hill. So this is a way of sharing these suitable areas between researchers and local farmers' organisations and the contractors. Something else we have been starting to work on through the Space for Smarter Governance programme is testing the feasibility of wall-to-wall soil moisture alerts. This is based on, and we've been testing this for using Sentinel-1 data, correlating Sentinel-1 returns with a number of sites where they're continuously monitoring surface soil moisture. And hopefully, well, that's one of our projects for next year to try to take forward with DEFRA. So our plans are to expand our activities into the US, South America. We have developing also some interesting projects in Brazil on compliance with agricultural regulations in Brazil. Southeast Asia, probably on palm oil. And look at other aspects of forests and agriculture, but possibly a depository service for EO data products with other universities in the UK. So expect continued growth and prosperity for the year ahead. And hope that's shared amongst everybody. Thank you very much.